Andy earns 28,000 rupees per month. He spends 1/4 of his income on food, 1/2 of the remaining amount on house rent, and 2/7 of the remaining amount on the education of his children. Let's find out how much money is left with him. For this, we need to know about rational numbers. We know that a number of the form p upon q, where p and q are integers and q is not equal to 0, is called a rational number. The numbers 7 upon 11 and minus 30 upon minus 43 are positive rational numbers. The numbers minus 6 upon 7 and 3 upon minus 8 are negative rational numbers. All integers are rational numbers. All natural numbers and whole numbers are also rational numbers. We can add, subtract, multiply, and divide rational. Let's look at the properties of rational numbers. We can add two rational numbers as we add any two fractional numbers. Let's add 1 upon 4 and minus 6 upon 4. Since the denominators are the same, we add the numerators. This is equal to minus 5 upon 4, which is a rational number. Therefore, we can say that the sum of two rational numbers is a rational. Let's now add minus 5 upon 6 and 4 upon 9. Since the denominators of both the fractions are different, we will find out the lowest common multiple, or the LCM, of the denominators. Now, on adding, we get minus 7 upon 18, which is a rational number. Thus, in general, we can say that if A upon B and C upon D are any two rational numbers, then A upon B plus C upon D is also a rational number. This is called the closure property of addition of rational. Let's now add the rational numbers 3 upon 4 and 1 upon 2. This is equal to 5 upon 4. Now add 1 upon 2 and 3 upon 4. This is also equal to 5 upon 4. Therefore, we can say that for any two rational numbers A upon B and C upon D, A upon B plus C upon D is equal to C upon D plus A upon B. That is, two rational numbers can be added in any order. This is called the commutative property of addition. Let's add the given three rational numbers. Adding minus 6 upon 7 and 3 upon 14, we get minus 9 upon 14. Now, minus 9 upon 14 plus 5 upon 2 is equal to 26 upon 14, which is a rational number. Now, add 3 upon 14 and 5 upon 2. This is equal to 38 upon 14. On adding minus 6 upon 7 and 38 upon 14, we again get 26 upon 14. This means that if we group three rational numbers in any order, while adding, we get the same sum. This is called the associative property of addition of rational. We know that 0 plus 2 upon 7 is equal to 2 upon 7. Also, 0 plus minus 6 upon 11 is equal to minus 6 upon 11. Thus, when we add 0 to any rational number A upon B, we get the sum as the rational number itself. 0 is called the additive identity for rational numbers. Look at these two rational numbers. On adding these, we get 0. So, minus 11 upon 13 is the additive inverse of 11 upon 13. and 11 upon 13 is the additive inverse of minus 11 upon 13. Thus, we can say that a rational number minus a upon b is the additive inverse of the rational number a. Let's subtract 3 upon 10 from minus 4 upon 5. This is equal to minus 11 upon 10, which is a rational number. Thus, we can say that rational numbers are closed under subtraction. Let's now subtract minus 4 upon 5 from 3 upon 10. This is equal to 11 upon 10. You can see that the answer in both the cases is different. Therefore, subtraction is not commutative for rational numbers. Similarly, you can see that subtraction is not associative for rational. Let's multiply minus 3 upon 7 by 5 upon 8. For this, we multiply the numerators and then the denominators. This is equal to minus 15 upon 56, which is a rational number. Thus, we can say that rational numbers are closed under multiplication. Now, on multiplying 5 upon 8 by minus 3 upon 7, we again get minus 15 upon 56. Thus, we can say that multiplication is commutative for rational numbers. Let's now multiply the given 3 rational numbers. This is equal to minus 24 upon 385. Also, if we change the order of the rational numbers, we get the same result. Thus, we can say that multiplication is associative for rational numbers. Look at this example. We know that the area of the path is equal to length into breadth. On solving, we get the answer. We know that 1 into minus 7 upon 3 is equal to minus 7 upon 3. This means that the product of 1 and a rational number is equal to the rational number itself. 1 is called the multiplicative identity for rational numbers. For every rational number a upon b, there exists a rational number c upon d, such that a upon b into c upon d is equal to 1. The reciprocal or multiplicative inverse of the fraction a upon b is equal to b upon a. The reciprocal of 1 is 1. The reciprocal of minus 1 is minus 1. Every rational number, when multiplied by 0, gives 0. Thus, 0 has no reciprocal. Look at the given example. On solving, we get 41 upon 36. On the other hand, multiplying 2 upon 3 by 5 upon 6 and 7 upon 8 gives us 5 upon 9 plus 7 upon 12. This is equal to 41 upon 36. Thus, multiplication of rational numbers is distributive over. Since division is the inverse of multiplication, to divide a rational number a upon b by c upon d, we will multiply a upon b by the multiplicative inverse of c upon d. For example, 3 upon 7 divided by 2 upon 5 is equal to 15 upon 14, which is again a rational number. Also, if we divide a rational number by 0, the quotient is not defined. Therefore, rational numbers are not closed. Let's divide minus 5 upon 9 by 3 upon 2. The quotient is minus 10 upon 27. Now, on dividing 3 upon 2 by minus 5 upon 9, we get the quotient as minus 27 upon 10. Therefore, division is not commutative for rational numbers. Look at the given example. Here we can see that the answer in both the cases is different. Thus, division is not associative for. Now that we know about rational numbers, let's find out how much money is left with Andy. The money spent on food is 7,000 rupees. The money spent on house rent is 10,500 rupees. The money spent on the education of children is 3,000 rupees. Hence, the amount of money left with Andy is 7,500 rupees. Let's summarize all that we have learned in this topic. Rational numbers are closed under the operations of addition, subtraction, and multiplication. The operations of addition and multiplication are commutative and associative for rational numbers. 0 is the additive identity and 1 is the multiplicative identity of rational numbers. For any two rational numbers a upon b, the additive inverse of a upon b is minus a upon b. The reciprocal or multiplicative inverse of a fraction a upon b is equal to